Number 14. Alright, what would we do first here? So if we add like terms, over here we have a 4x plus 1. Over here, 2x plus 2x is 4x plus 8. If we subtract the 4x from each side, this cancels, so we get 1 equals 8. Does 1 equal 8? No, so that's a no solution. So anytime your variables cancel, it's one of two options. It's either no solution or infinite solutions. If you're left with a false statement, then it's no solution. If we were left with like 1 equals 1, then that would be a true statement. And so then in that case, it would be infinite solutions. Number 15. So I'm guessing on this one, it's probably the fractions that made it challenging. But what you need to realize is this is just linear. So what would we do first? Okay. We distribute. That gives us a 2/7 x minus 8/7 minus x equals -4 minus 3/5 x. Now you could try, if you wanted to multiply by something and get rid of all the fractions, you certainly could, but we don't have to. We can deal with fractions. We have calculators. It's not a big deal. So if we look at like terms, 2/7 x, we can do it. Minus. Okay, this is just like 2/7 minus 1. So that's a -5/7 x. So then, if we're trying to get the x's on one side, we would add over the 3/5. And the -8/7, we would add that over. -5/7 plus 3/5. So if you're doing it on your calculator, you just do, like parentheses, -5 divided by 7, close your parentheses, plus 3 divided by 5. And you can do math number 1 to turn it into a fraction. So we would get -4/35. Okay, over here, -4 plus 8/7 is -20/7. Then what do we do? Divide by -4/35. One multiplied by the reciprocal, they are the same thing. So if you do that, we get a positive. No, not 35, 25. Okay. Question 6. Problem 17. Bob invests $22,000 Some at 7%, some at 6% annual interest. If after 6 months he receives a return of $710, how much is invested at each rate? Okay, what would we do here? Make a chart. So, we did the chart anytime we had a lot of information to organize. We are talking about interest, so our formula always went at the top. So my interest formula is principal times rate times time equals interest. And then we made rows for each of the things we were doing. So we had a 7%, we had a 6%, and we had a total. What other problems did we do with this table? Concentration. Do you remember on the concentration problems, what we put across the top?
Something times percentage is equal to amount pure.
Yeah, the amount times the concentration equals the amount pure. Okay. So now what do we do? So we have some at 7%. So do I know how much? No. But we know it's $22,000 that he has altogether. So that is my total principal. We don't know how much we're at 7%. So then we have to figure out the 6%. Can I just call that X as well? No. What do I have to do? Okay, my rate, 7% would be 6%.
0.07. 0.06.
Okay, my time. Time is always measured in years. It said 6 months, so how much of a year is that? 0.5. All right, and then at the end he had $710 interest. So where does that go? Does it matter that I don't have an interest rate here? No. Our goal is to get this final column. So if we have the number, then it's okay if there's blanks somewhere else. For these, we're just going to use our formula. P times R times T. So X times 0.07 times 0.5. 22,000 minus X times 0.06 times 0.5. So it would be 0.03 times 20,000 minus X. And you could certainly go ahead and distribute that if you needed to. All right. Now what?
Take 0.235x plus 0.23 times 22,000 minus x is equal to 710.
And it's always the first one plus the second one equals our total one. So we have 0.035x plus, so 0.03 times 22,000 minus 0.03x equals 710. Combine those, we get 0.005x. Subtract over the 660. Divide. So we get 10,000. So then to find the other one, that was 22,000 minus x. So that's 12,000. And then what do we have to do to finish it? Write a sentence. So Bob invests 10,000 at 7%. And 12,000 at 6%. that okay? Alright, so the next one we asked about was problem 19. We want to be perpendicular to this line and going through the point forward. Alright, perpendicular. What does that mean?
Perpendicular. Slope is opposite reciprocal.
Right. They meet at a right angle, so slopes are opposite reciprocal. If I said parallel, what would that mean?
Same thing.
Same slopes. Okay, if I want to find the slope, we have to get it in slope-intercept form. Y equals mx plus b. So if we subtract our 2x, divide everything by negative 5. So the slope of this line currently is 2/5. That's all I need that line for. When I come over here, I want to be perpendicular, so what slope do we use?
-5/2.
Flip it and change the sign. And then we plug into, you guys liked point slope form if I remember correctly. So the y value is 1, my slope -5/2 times x minus the x value, which is 4. So y equals -5/2 x plus 11. That is, oh, like to find your b? Oh, absolutely. Right. Questions there? So if I said parallel, then your slopes would be the same, perpendicular, opposite reciprocals. 21. So in problem number 20, we found that the slope was -3/5. Now I want the equation. So you take one of those 2 points. It doesn't matter which one. So if I went with the first one, that was -7, 4. So then plug into either y equals mx plus b or the point slope formula. So y minus the y value equals m times x minus -7. So x plus 7. So y minus 4 equals -3/5 x minus 21/5. Add the 4, so -3/5 x minus 1/5. So you had to use the slope that you found in problem number 20, and then one of those 2 points, and it would not matter which one. Is that okay? 22. We want the distance between the points in problem 20. So these were the 2 points. What's the distance for me?
Square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared.
So this is like x1, y1, x2, y2. So 3 minus negative, so plus 7 squared. -2 minus 4 squared. 7 plus 3 is 10, squared is 100. -2 minus 4 is -6, squared is 36. So we get the square root of 136. You know that I want exact values for the final answer, so no decimals, but we do need our radicals to be in lowest form. So 136, that's divisible by 4 and 34. So square root of 4 is 2, 34 does not break down. So 2 radical 34.
Okay, I just put it in decimal form. That's
Ah.
what I had.
Yeah, I'm always going to tell you exact values, so no decimals. T4. So first we subtract our 3. always, whether you're doing an equation or an inequality, you have to get the absolute value by itself first. Then at this point, we have to make two separate equations. One of them, nothing changes. The other one, you set it equal to a negative, because we know absolute value takes the positive or the negative number and turns it positive. So then we add our 6, divide, so we get 11/5 and 1/5. And what can you always do at the end of these? Plug them back in and check it. So on problem number 23, when you solved your two separate equations, you should have gotten 6 and 1. But I said the final answer was only 6. Why? 1 didn't work when you checked it. Right. We're okay on 25. So let's look at 26. Okay, there's two approaches to take here. We have fractions. We did another fraction problem earlier, and we can just deal with it. We know how to, it's just linear, x is to the first, so x over 7, you could think of that as a 1/7 x and work from there. The other option is if you're really opposed to fractions, you could multiply by something and get rid of them. Which route do you guys want to go? Last time I dealt with it, let's get rid of it this time. That way I'll show you both options. So my denominators are 7 and 3. What would we have to multiply by? Cancel both a 7 and a 3. 21. And that's every single term. So we're taking everything on each side. Okay, so 21 divided by 7 is 3, so that's a 3x minus 63. It's greater than, here 21 divided by 3 is 7, so that's 7 times my x minus 4 plus 21. You guys okay with me there? So if we work this out, we have 63 greater than 7x minus 7. If I subtract over my 7x, add over my 63, when I divide by a negative, what happens? So I get x is less than negative 14. How do I want you to always write your final answers if it's interval or at inequalities? Intervals. So less than that would be negative infinity to negative 14. All with parentheses because there was no equal to. Last problem we asked about was 33. So, okay, f times g. So here's f times, here's g. Okay, keep in mind, each of these are just over 1. So if you just distributed, you would get x squared over x minus 3x over x minus 4 over x. And then you can reduce. X squared divided by x is x. This one that would just give us a 3 minus 4 over x. And that's as far as we can go. B, g composed with f, so that's g of f was x squared minus 3x minus 4. So I go to g and I replace my x with this. And you're not solving anything, you're just writing that expression. So that's our final answer. Is there anything else that you want to look at? Yes.
Oh, we did it, but I have a question about these. So if we were to write it in parentheses on the test, we can kind of write it wrong.
Have you factored it?
Well, oh, that's still correct. So if you put
Like, I've got,
1 over x minus 4, x plus 1.
Yep.
That's fine.
I want to make sure we can write that up the test. 'cause
Yeah,
I always-
I will take it. Absolutely.
Just an overachiever.
How? It's simple.
You're just doing extra.
You know what?
Bonus.
Just because you're lazy. Doesn't
And who hasn't even started chapter 3?
That's because you
Any
thought we had to go through chapter.
others?
I did think that we had to go through chapter 3, so I was like,
So,